To continue in my alternative fuel vehicle series, I wanted to show off an electric vehicle today to help show some of its main components, ways that it's similar and not so similar to a gasoline vehicle, and also show what makes it tick. So today we have a 2016 Nissan Leaf. This is an all-electric vehicle capable of traveling about 107 miles in electric vehicle range on one charge, and overall performs and acts very similar to a gasoline vehicle with a lot of pep thanks to its electric motor. So let's jump into the Leaf to check out its different parts and components. At the onset, it looks very similar to your regular run-of-the-mill vehicle. You have your steering wheel, your gear shifter, though it is worth noting, since there is no transmission on this, you're able to use a very different gear shift design, one where it just has a little nubby there. Really, overall though, it looks very similar to your typical vehicle. However, underneath the hood, things start to get a little bit different. Now, as I said before, this is a dedicated electric vehicle, a full EV. That's different than a plug-in hybrid or a regular hybrid, where you have a gasoline motor to take over on some of the driving if you run out of electric charge or if you hit a certain speed. This is all electric all the time, and it really has quite a lot of pickup too. It's very comfortable cruising at high speeds and able to really hold its performance. So what you see here, it might at a quick glance look very similar to a regular engine bay. However, the components are very different. You have your 12-volt car battery, so that's regular right there. However, up here, you have your electric motor connected to an inverter. That's where you see some of these very large orange lines running. An inverter which is connected to the batteries that are on board. And those batteries are giving a bunch of electricity to the motor, which heads straight to the wheels. You can see some of that axle work down there. And those wheels are able to turn instantly. So that's where you refer to electric motors having instant torque. That just simply means that there's no transmission here. So in order to get energy to the wheels, it takes less mechanical moving parts, which means you have quicker acceleration than on a typical gasoline vehicle. So where do those batteries actually sit? Let's check that out. Now, on different types of vehicles, batteries can either be underneath a back seat or even run through the middle of the car. On the Leaf, however, the batteries sit directly underneath in the floorboard. So what you see here, it might not look that impressive, but notice that there's no real air gaps. It's all very flat. That's because these are the lithium cells themselves, just packaged right underneath. Some of you might say, well, that doesn't sound very smart. What happens if something were to nick it as you're going along? Well, the good news is they're very well reinforced, arguably safer than a gasoline tank that would sit underneath, as there's just simply more shielding to it to protect it. And to get all that electricity to those batteries, let's see here. Let's push this button. We have a charger. Now this Leaf actually comes with two modes of charging. I'll go into that in a little bit, but this is where you connect an electric vehicle charger, and that is what allows the electricity to charge. Another cool thing to point out about this model is in the back, we have a photovoltaic cell up top, a solar panel, and this solar panel actually feeds directly to the 12-volt battery on board. So that means you'll never really be left with a dead battery, as it's always going to be charging when the sun is out, while also charging off the batteries once it's up and running as well. Okay, very interesting, you might say, but let's get back to that charging. How much charging does this vehicle require? Well, at the very basic level, we have what's called a level 1 charger. It is literally just a connector plugging straight into a 3-prong outlet. It's the slowest form of charge. It's a charger that comes stock with the vehicle. And to plug it in, you just simply pop open this cap. Got to get the cover off here. Plug it in. And then you just would need to plug it in to any other 3-prong outlet. Now this is the slowest form charge, as I made mention. We're talking about 2 to 4 miles of electric range an hour. Very slow. But there are faster forms of charging out there, typically found in public settings, and some of those are going to provide a faster rate of charge. But at the very basic, you have this. This is most often popular with a lot of electric vehicle owners to use overnight. You park it in your garage, plug in your car, and you use it to top off the battery. Overall, the thing to always bear in mind with electric vehicles, and really vehicles overall, is how many miles you are using in a typical day. How far away do you live from your work? What type of errands do you run? You probably will find you don't actually put that many miles on during the day as you typically think. So that's to say, the battery will never really deplete, but rather you'll just simply be topping it up overnight, have a fresh battery ready for the next day, and you have public charging around to top up as well as you're moving about. So how does an electric vehicle drive? Well, as I mentioned earlier, it doesn't have a transmission, which means they're really quite spirited to drive. And you have what's called instant torque. So as I can show right here, you have a lot of pickup. The energy is able to flow straight to the wheels, which means it's a really fun car to drive. And this is typical for a lot of electric vehicles, both dedicated electric and plug-in hybrid. You can have a lot of power and torque, especially in that immediate upfront portion. So even against a really fast, super-powered car, you might beat it in the first 50 feet off the line. But in general, it's a pretty quiet cab. They really have focused on designing the Aero Package on a lot of these electric vehicles to minimize road noise, because without the engine up front, you actually can hear more of the wind as it blows around. So that's why you can see up front different bumps and grooves that helps make the air move around the vehicle efficiently and also help minimize road noise. But another thing to point out is, I'll show it down here. You can see I have a power indicator readout. Now, this is what's referred to as regenerative braking. So you'll see it go into the white as I'm accelerating. And then I'm coming up to a red light here. So what I'm gonna do is I'm gonna let off the brakes, and you see it start going into the green. That's regenerative braking. The motor is actually collecting energy I exerted and putting it back into the battery. By doing that, that helps conserve energy and ensure that not much of it is wasted in the form of heat loss through the brakes or other frictional losses. So that overall helps give you actually a pretty good range and make sure that you're using the energy as efficiently as possible. Otherwise, a lot of the driving experience is the same. You still have a lot of nice room in the cabin, and it really is overall a great driving experience. So for public charging, the most typical and popular option you'll find is what's called level 2. This is a step up from the level 1 chargers that I showed earlier. It's the same type of connector. This is called a J1772 connection. It's the universal charging standard for majority of electric vehicle chargers. And while the one I showed you that you use at home provides anywhere from 2 to 4 miles of range an hour, this would give you 10 to 22 depending on the type of vehicle that you have. So a little bit faster of a charge, one that's able to provide you an even better top up. And then at the very top, this unit that you see here, you can see it whirring up because I've already plugged it into the Leaf. This is what's called a level 3 DC fast charger. It provides a lot of electricity at a very high rate. So while those, the level 2 and the level 1 were giving 2 to 20 miles of charge an hour, this will give you 20, 50, 70 even miles of charge within 20 minutes. So it's really fast charge. The reason for that is those ones are using alternating current. This is direct current. So this is what you find with the Tesla supercharger network, as well as these chargers here. There's a number of different connections. You have the CCS combo. That's literally just the J1772 connector with 2 bigger prongs also attached to it that gives you a really fast charge. And the charger that I'm using is what's called CHAdeMO. I'll show you right here what it looks like. As you can see, it has a lot more prongs to it, a much beefier connector than that J1772. And again, this is what provides a really fast, dense charge. The CHAdeMO is really popular with Japanese brands. That's what the standard is for. So subsequently, Nissan, a Japanese manufacturer, is using that as their DC fast charger. The CCS combo is a more popular option with the German manufacturers. So BMW, for instance, is going with that. Another instance that you'll find too is in China. They're using another standard as well that provides level 2 and DC fast charging within the same connector. So you have a lot of these different types of chargers around town. But the one universal thing for majority of them is that they do use that J1772 standard. and that is a universal connector good on majority of the EV chargers. So while it seems like there's a lot of different connectors out there, you're not quite sure if it's going to be able to connect to your vehicle, the J1772 standard remains a top standard for everyone involved. So that's an electric vehicle in a nutshell. I just want to give a quick overview to allow folks to check out the vehicle, go through a lot of the quick options. I'm fortunate to have a lot of the different public charging options around town. So if you have any questions, feel free to comment below. And if you have any suggestions for upcoming videos, feel free to comment and subscribe to see those videos as they come out. Thanks so much for watching, guys.